Every year, more than 140 billion Lego pieces are manufactured. It is such a massive number that, if all of them were placed one after another, they could circle the Earth more than 10 times. But how does something so small become one of the most popular toys on the planet? To find out, we enter the Lego facilities to discover the process. This story did not begin with machines or polymers, but with wood. In the 1930s, when toys were still a luxury and technology was far from automation, a Danish carpenter began crafting small toys from leftover scraps in his workshop. The company grew through difficulties until a fire forced a complete redesign of the production line. Instead of giving up, they took a risk on a material that was beginning to revolutionize industry: plastic. Decades later, that choice sparked a transformation that turned Lego into an international phenomenon. The idea of a brick that could attach to another with absolute precision led to more advanced design systems and the creation of molds that marked a turning point in the world of play. Modular construction became an unlimited experience, and with it, global demand continued to grow. So, how is the most requested toy among children, and even adults, manufactured today? It all begins long before a child opens a box and finds brand new pieces. The journey starts when enormous trucks loaded with plastic granules arrive at the factory. This material is chosen because it resists impact, maintains its shape, and keeps its colour even after thousands of uses. The trucks unload close to 28 tons each directly into outdoor silos that function as strategic reserves. From there, the granules are pulled through a pneumatic system that carries them through long metal ducts, as if an invisible river were continuously feeding the plant. Every particle is inspected to ensure it is clean and free of imperfections, because even the smallest variation in shape or texture could cause a brick to fail to connect as it should. Once inside the factory, these tiny granules still have no identity. To give each piece the exact colour required by the design, the plastic goes through a dosing and mixing stage with concentrated pigments. Precision is as important here as in any other phase of production. A blue brick produced today must look identical to one someone saved in their home 30 years ago. For this reason, the colour formulas follow strict standards to ensure complete compatibility, regardless of where in the world the brick was made. The pigments are incorporated uniformly through a vacuum system that transports the material in a closed circuit. This prevents contact with moisture or particles that could change the texture of the plastic. Environmental controls are constant. Air temperature and humidity are monitored at all times because any variation could alter the final tone or even affect the characteristic shine of Lego pieces. During this stage, the granules begin to feel like more than raw material. They acquire the first trait that will make them recognizable to millions of children and collectors: their color. When the plastic is perfectly colored, the physical transformation begins. It is the stage where the solid granules are turned into a moldable mass. The material enters a heating cylinder where the temperature rises to about 230 degrees Celsius. As it moves through this thermal chamber, a rotating screw pushes it forward while heating it and pressing it with controlled force. Each turn breaks the rigid structure of the granules and mixes them until achieving a uniform paste without bubbles or clumps that could affect the final result. It is similar to slowly pressing a thick dough until it becomes completely workable. Viscosity is crucial in this moment. If the plastic becomes too liquid, it could flow too quickly and deform the pieces. If it is too thick, it would fail to fill the mold. This is why sensors and control systems monitor the exact point the mixture must maintain. The plastic becomes a thick and hot paste, almost like an industrial version of freshly squeezed toothpaste, ready to take the exact shape dictated by the molds. Everything happens within seconds, ensuring a constant flow toward the next stage. The melted material, now with the thick and uniform texture of a hot paste, moves toward the molds. Through a high-pressure injection system, the flow enters machined steel cavities that define every detail of the final piece. This includes outer walls, connectors, and internal reinforcements that create the distinct click between components. Each mold is a piece of engineering made with extremely tight tolerances, sometimes only a few micrometers, to ensure that all pieces fit together perfectly without gaps or deformation. These molds, made from hardened steel, can weigh anywhere from 150 to more than 1,500 kilograms, depending on the complexity of the design. Inside them, the injection channels distribute the material with millimeter precision, filling every corner in a matter of seconds. As soon as the mold closes, a network of cooling channels begins to circulate cold water under high pressure, reducing the temperature of the molten plastic and solidifying it almost instantly. It is a process as fast as it is precise. In less than 10 seconds, the liquid mass becomes a perfectly defined solid shape. When the mold opens, the scene is hypnotic. Newly formed pieces emerge from inside, still shiny from residual heat and aligned with surgical precision. They look like tiny, freshly unmolded tablets, identical to one another, ready for the next stage where they will be inspected, trimmed, and prepared to be assembled into larger sets. Each one preserves the exact shape given by the mold, ensuring that millions of pieces manufactured in different parts of the world will fit together with the same perfection. Once the pieces cool completely inside the mold, it is time to eject them with absolute precision. A set of small pistons pushes each piece outward so it falls gently into padded containers that protect their freshly formed edges. Although Lego bricks seem simple and robust, they can still be easily marked at this stage, so the fall must be controlled and free of sudden impact. Ejection is a critical moment. If a piece remains trapped or fails to exit in the exact position, it could damage the mold, an extremely expensive and essential tool for production. This is why electronic sensors supervise every movement. They detect whether a piece has not been released, whether one is missing, or whether the ejection occurred with the correct force. Surveillance is constant and automatic. Even here, when the brick has just been born, the first quality control begins. The surface shine is inspected, the dimensions are confirmed, and the color consistency is checked. The level of accuracy is so high that only about 18 pieces per million are considered defective. It is a minimal margin, the result of a process designed so that nearly every piece is perfect on the first try. While the machines continue their constant pace, the bricks pass their first test before moving on to the next chapter. When the containers beneath the machines fill with freshly molded pieces, automated arms bring the process to a new level of organization. Sensor-guided vehicles take each container and transport it without human intervention to a fully automated warehouse. There, the boxes are compressed gently to occupy the least possible space as they enter a shelving system that seems endless. Robotic cranes travel through narrow aisles that together extend more than 70 kilometers. This place could be described as a library of bricks. Every container has its precise shelf, and every piece is catalogued with exact information about its quantity, its type, and the moment it will be needed. The system maintains full digital control. If a future box needs 100 red bricks of a certain size, a single command triggers the machine to locate the correct container, remove it, and send it to the designated area without the slightest margin of error. Automation here is not only about efficiency, it guarantees that every correct component arrives at the packaging line in the exact order needed to create a complete set. But not every piece remains as it comes out of the mold. Some require a final touch that gives them personality. The heads of minifigures, torsos with detailed uniforms, and elements with specific symbols move into decoration rooms where faces, outfits, or insignias are applied using screen printing and pad printing. Clamps and suction tools hold each piece in place so it cannot move even a millimeter, while high precision stamps apply perfectly aligned layers of ink. A single production line can decorate up to 15,000 heads per hour. They smile, frown, or show unique expressions, but all must maintain complete consistency. The height of the eyes, the angle of the mouth, and every tiny detail are checked with optical sensors that detect variations impossible for the human eye to catch. The ink dries quickly, and its adhesion is tested to ensure that the small face will not wear off even after hundreds of hours of play. Piece by piece, characters from the Lego world come to life inside the factory, ready to join the universe of creations that each child will imagine later on. As the decorated pieces move forward through the factory, others are already ready to become characters. Minifigures are assembled like small modular robots. The torso and legs are pressed together with a specific force, strong enough to remain connected for years of play while still allowing the legs to bend without losing stability. The heads snap onto a central tube that defines their range of motion, and the arms are inserted into tiny cavities designed to rotate smoothly without ever coming loose. At this stage, technicians also verify that each joint responds evenly. When the characters and bricks are ready, it is time to create the sets. Optical sensors and high-precision scales count every type of piece that the model requires. If a set needs 23 black bricks, 1 helmeted minifigure, and 2 transparent windows, the machines ensure that nothing is missing or extra. The parts destined for the same section of the build are grouped inside a bag that is sealed with a small amount of air to protect the pieces from impact during transport. It is a simple detail, but it prevents damaged edges or scratched surfaces. Each bag goes through a chain of 6 consecutive weight checks. It is a fast but rigid process. If there is even the slightest variation, even the weight of a single tiny piece, the machine removes the bag automatically for manual review. Once all the bags are complete and verified, they move to the final packaging area. Here, machines place each group of pieces inside the correct box alongside the printed instructions that guide the construction step by step. The manuals do more than explain how to build the model. They are designed so that anyone, regardless of age or experience, can follow the process easily. They are the roadmap that transforms that group of pieces into an airplane, a dragon, a futuristic building, or any other design created by the development teams. The boxes are sealed automatically with a uniform closure that ensures the contents arrive intact. They are then labelled to identify the product, the destination region, and complete traceability. Once ready, they are stacked on standardised pallets that make international transport easier. From this point on, the system records every movement. It tracks exactly how many boxes are produced, where they are shipped, and when they must arrive. Nothing is left to chance because a delay or a shortage can affect availability in thousands of stores around the world. The pallets are transported to large logistics centres where the global phase of the journey begins. These centres function as strategic hubs that supply different international markets depending on demand. Everything is tracked with internal codes that allow each product to be identified from the factory to the shelf of a store in any country. And that is how millions of Lego pieces are produced every day. Tell me, did you already know about this process? I will be reading your comments. If you enjoyed it, give it a like and subscribe. In the windows you will see next, there are more industrial process videos as fascinating as this one. See you next time.